Yeah, good morning, friends.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. No need to send the reply message. Just to start for the today's class. This is the first class of this semester. So I have typed this good morning message. Okay, no need to reply for me. Okay, no need to unnecessarily fill the chat box. Huh? So how was your last semester?
It was good, sir.
It was good. Okay. You are in third year or fourth year?
Fourth year.
Fourth year.
Okay. 60 students has been registered for this course. Okay. What is the necessity of registering for this course? Any idea on this course, soft computing? If you are registered here, what is the need for registering this course as a program elective? Whether it is on your interest or somebody forced to register for this course. Please come out with their answers, that is right or wrong. At least we can have some discussion. Somebody forced you, or due to compulsion, no other electives has been offered, so you have taken this course, or what is the importance of this course? Any idea? So 50 students are there. All 50.
No, sir. In Excel sheet they have given this course, sir.
Which one, ma?
This course has given in the Excel sheet, sir. In A1
Excel
slot,
sheet,
we have registered in this.
Okay, you have registered it. Do you have any idea about this course? Do you have any idea about this course?
No, sir.
No idea. Okay. This course, soft computing. What do you mean by soft computing? Any idea on that? Have you gone through the syllabus? I have already uploaded the syllabus. Have you gone through the syllabus? Have you gone through the syllabus?
No, Professor.
No, sir.
Yes. You didn't go through the syllabus, which has been given in Microsoft Teams. Okay. So there are two types of computing is there. So one is considered as hard computing and other one is considered as soft computing. The hard may be considered as traditional computing. Okay. So the difference between these two, the hard computing and soft computing. Have you come across data structure subject? You have completed, no? The first year.
Yes, sir.
You have studied. Okay. So in data structures, you are the theory of computation. You come across with the two different types of problems. So one you can consider as NP complete and other problems you have heard about, no? NP problem, NP complete problem. Have you heard about those problems in data structures or theory of computation? Have you come across these terminologies? I think in module number 6 or 7 you have dealt with, I think so. These concepts. Have you come across these problems?
Yes, sir.
So, yes. Okay. So in the case of hard or soft computing, with respect to hard computing, so we can able to identify the solution. We can able to identify the solution in a easier manner. Okay. And we can able to find a optimal solution. Optimal in the sense is that may be the exact solution or that may be the right solution. So for that purpose, the hard computing strategies or hard computing techniques or hard computing methods, whatever may be the case, all these things can be applied and you can able to solve those problems. And the soft computing is nothing but where higher number of iterations are required, more approximations are required, and then the problem or the application is considered to be complex. In such cases, where your hard computing or your traditional computing cannot able to solve or cannot able to provide results or provide the outputs. In such cases, so we are trying to replace that hard computing with respect to soft computing techniques. So this soft computing is in the domain of artificial intelligence. The soft computing is in the domain of artificial intelligence. So in artificial intelligence, you have a subdomain called the computational intelligence. The soft computing can be otherwise considered as computational intelligence. So this computational intelligence, it consists of various fields, subfields, or various subdomains. So the first subdomain may be considered as neural networks. The next subdomain may be considered as the fuzzy logics or fuzzy applications or fuzzy concepts or fuzzy set theory, whatever may be the case. And the next one may be considered as evolutionary computation. Again, in evolutionary computation, you have again subdomains like evolutionary algorithms will be there, genetic algorithms will be there, then genetic programming is there, evolutionary programming is there. So in evolutionary computation, EC, you have again some subdomains are there. And the next one may be considered as RST. It is considered as rough set theory. And next one is nothing but the conventional or traditional AI techniques or AI methodologies. So put together all these domains, subdomains or all these domains grouped together or put together, then we have given a new name called soft computing. We have given a new name called soft computing. Okay. So in the course soft computing, so we are going to study on these three domains. So the first domain is considered to be the neural networks domain, module 1 and module 2 and module 3. So the three modules is going to be covering, we are going to cover neural networks. And then module 4, module 5, module 6, we are going to cover fuzzy concepts. And then apart from that, module 7, we are going to cover the search strategies is nothing but the evolutionary computation. In the domain of evolutionary computation, so we go with the GA concept, is considered as genetic algorithms. And then the next one is nothing but here module number 8 is the applications of soft computing, which will be handled by our industrial friends. So the textbook for this course. So with respect to module 1, 2 and 3, that is nothing but the neural networks, then the memory models of neural networks and unsupervised neural networks. Okay, these three modules, we need to go by this book. The only textbook you have is Sivanandam and Deepa, that you can follow it up. Otherwise, for this module 1, 2 and 3, neural networks architecture by Simon Heiken is there. So that is the standard textbook of, across the globe. It has been followed across the globe. So 1, 2 and 3 module. Then module 4, module 5 and module 6. So that deals with the fuzzy concepts or fuzzy set theory. So those three modules will be covered with the fuzzy logic with engineering applications by Timothy J. Rose. That was the standard textbook which has been used across the globe. So these two textbooks you need to cover, and especially with respect to genetic algorithm, we have one more textbook which is considered as genetic algorithm search optimization and machine learning is Davis E. Goldberg. So with respect to 4, 5, 6 fuzzy logic with engineering applications, Timothy J. Rose will be the good book, and then neural network Simon Heiken will be there. If you want an Indian author, then you can go with Rajshekaran and Pai, which is an Printage Hall of India edition. And then next one is the module number 7, genetic algorithms. You need to go refer Davis E. Goldberg, which is Pearson's Education Press. And then this is not required. Fuzzy sets, fuzzy logic theory and application. This Yuan and Clear is not required. So the first 4 books is recommended for this particular course. So we say that the soft computing is a collection of various domains. So the first one may be the neural networks, second one may be the fuzzy, and the third one is nothing but the genetic algorithms. So can you guess what do you mean by neural networks, and what do you mean by fuzzy, and what do you mean by genetic algorithms? Any idea on that? Can you guess? So what is the overview of these three subdomains which has been put up together, and then we call it as a soft computing strategies or methodologies or techniques, whatever may be the case. Any idea on that?
சாய்பாபா அவங்களுக்கு தானே போட்டேன் இல்லையா? சாய்பாபா இது அவங்களுக்கு தானே போட்டேன்.
Hello.
இங்க கவர்மெண்ட் ஹாஸ்பிட்டல்.
Okay. Any idea on this neural networks and other things?
Neural network applies a series of algorithms to study the underlying pattern of some data.
Okay, underlying pattern of some data. Okay. Any other thing? Okay. So it is nothing but the neural network. All these subdomains. One is neural network. Another one may be the fuzzy or the genetic algorithm. So all works or all these methodologies or domains are nothing but they are mapped to our human behavior. So the soft computing techniques are the soft computing methodologies. So all these things are try to mimic the behavior of the human beings. Okay. So with respect to neural networks, if you see, so how the human brain works, similarly the neural network works. So it is considered as artificial neural network. So the traditional neural network is nothing but the human brain. So how the human brain is connected with the various nerve systems, then you may have synapses will be there, synaptic nerve will be there, so many things are there, dendrites will be there, so many things are there. Similar on the processing power of a human brain, then memory capacity of the human brain, all those things. So how a human brain works, similarly the neural network works. So that's why they call it as, so instead of calling it as NN, simply neural networks, we are calling it as ANN, which is considered as artificial neural networks. So that is the mapping of the human brain that has been dealt in the neural networks. So how the human takes decision, so how the human reacts with respect to a particular situation, so how the human handles a specific application. So all those things are nothing but the concepts which we are going to deal with respect to neural networks. Then in the case of fuzzy, so before entering into the fuzzy set, so you need to know about what do you mean by classical set or what do you mean by crisp set. So classical set or crisp set is nothing but, so it is the set which consists of definite values. It consists of a definite values. Definite values in the sense is nothing but, so you may have either true or you may have either false. So only these two are possible with respect to the crisp set or classical set or traditional set, whatever may be the case. So all are same. So you can call it as classical set, you can call it as crisp set, or you can call it as the traditional set. All are same only. So this crisp set or classical set or traditional set, whatever may be the case, so they have a definite values. Okay, definite values in the sense is nothing but, so if you take a simple operation of an AND gate, whatever you have studied in the digital logics. So in the case of AND gate, if both the inputs are high, we can say that the output will be high. If any one of the input is low, we say that the output will be low. So a high and low are yes or no. That is the two different states which exist in the crisp set or classical set. But in the case of fuzzy set, so fuzzy is just the opposite of that. Okay. So fuzziness is nothing but the vagueness. Fuzziness is nothing but the vagueness, or it is considered as randomness. There is no concrete what you can call it as a decision making process will be done in the case of fuzziness. For example, you can take the performance of your internal assessment examinations. So internal assessment examination, you can say in the CAT examinations, either CAT 1, CAT 2 or FAT examinations. So whenever you complete the exam and whenever you come out from the examination hall, okay, so you can discuss with your friends that how was your exam today. So you and your friend are discussing. In such cases, so one of your friend may say that there may be a 50-50 chances. So cat on the wall. So if the valuation is little bit liberal or the valuator is somewhat relaxed, then I may able to pass in this particular course. Or if the valuation is so strict or the valuator is so strict, so I may lose this examination or I may lose this particular course in the internal assessment. So like that, we are not concrete whether I am not going to conformly say that I will surely get pass mark or I am going to surely get a fail mark. What is the case? That is considered as vagueness. Okay, this fuzzy set deals with this vagueness, and in the case of crisp set, you call it as what you can call it as you have yes or no, but here it deals with vagueness, uncertainty, randomness, all those things it is going to deal. So though it is going to deal with this uncertainty, vagueness, and we cannot able to have a concrete yes or concrete no or concrete true or concrete false. So in such cases, the fuzzy values will be between this yes or no or between this true or false. So always the fuzzy values, the lower limit will be 0 and upper limit will be 1. And in between these two, lower limit and the upper limit, this true and false or yes or no, you may have so many intermediate states or you have so many intermediate values. So all those things are dealt by this fuzzy set theory or fuzzy concepts. And the next one is nothing but the genetic algorithm. So genetic algorithm, again, it tries to mimic the behavior of a human genome pattern or human gene pattern. So that's why they call it as genetic algorithm. So how the reproduction has been done in the human body and how the what you can call it as the selection of the genes has been taken place. So all those things we are going to discuss about with respect to genetic algorithms. So this is the overall view of the course soft computing, and this soft computing consists of J component, that is nothing but for the 4 credits. So for the J component, already I have created the link in the Microsoft Teams. So here what you are trying to deal with this J component, the theme of J component should be either COVID-19 issues. You need to take up COVID-19 issues and then you need to provide the solution for this COVID-19. The recent one is nothing but the Delta version. So either you can consider the theme of initial COVID-19 or you can consider the recent COVID-19 Delta version. So those theme only permitted for your J component. Apart from this COVID-19, so you can take UN nations SDG goals. So UN nations SDG goals, UN nations has given 17 SDG goals. So 17 SDG goals is nothing but sustainable development goals. This sustainable development goals, it starts with the education, poverty, hunger. Then the next one is nothing but the what you can call it as the smart cities. Then life on land, life below water. Then the next one is gender equality. Like that, you have so many things are there with respect to sustainable development goals. So then the next one is healthcare, then quality education. So like that, so many things are there. So you can see here these 17 goals. So first one is how to remove the poverty, then zero hunger, then good health and well-being can be COVID-19 can be brought under this, then quality education. So how the education can be improvised during this pandemic or non-pandemic situation, then gender equality, how a male and female has to be treated equally, clean water and sanitation, affordable and clean energy, like nowadays the traditional energy or the traditional energy sources have been moved out now. So they go with the other upcoming new energy sources or energy types. The next one is nothing but the economic growth, industry innovation and infrastructure, then reduced inequality, then sustainable cities and communities may be considered as smart cities, then climate action, life below water, life on land, peace and justice, partnerships to achieve goal. Like this, so many things are there. So these 17 goals. So by 2030, the whole globe has to overcome all these issues. So each and every goal, you may have certain issues are there. So those issues needs to be addressed across the globe, and then we need to find out the solutions for that. So either two chances are given or two options are given for the student friends. So one option is either you need to take up SDG goals. So once you take SDG goals under good health and well-being, you can cover this COVID-19 issues, or only COVID-19 you want to take, you can take. So your project titles and your project works should be only in these two options. One is SDG goals, 17 SDG goals, and the next one is nothing but the COVID-19 issues. The recent one is Delta version. And the next one with respect to digital assignment 1, 2, and 3. So totally 3 digital assignments you need to do. One digital assignment I can give it as, so whatever the goal you are trying to choose or whatever the problem statement you are trying to take. So for that problem statement, okay, down the line 10 years, you need to collect the detailed and exhaustive literature survey or related works, and you prepare a document, and that document needs to be submitted. Okay. So for the J component, whatever you are considering as a problem statement, okay, so that problem statement has to be considered, and you need to do a detailed survey or exhaustive survey, and then you have to submit a document. So what are all the existing works, and what are all the drawbacks of the existing models or existing methods, and how you are trying to overcome those things through your proposed architecture or through your proposed model. So that is expected in the digital assignment number 1. And digital assignment 2 and 3, okay, so already I have given over there. So you need to take any of these 3 websites you need to visit, any of these 3 websites. The first website may be the GitHub, and the next website may be the lead code, and the next website is InterviewBit, and the last one is nothing but Kaggle. So any of these 3 or 4, you please go through those websites, and you try to collect or try to gather certain open issues are there or open problems are there. Okay, so those open problems has to be solved, and then you need to first create your profile in these platforms, either lead code or InterviewBit or Kaggle or GitHub. You need to create a profile, and once the profile is created, then you need to take up some of the issues or some of the open problems. So, and then you try to solve those problems, and then at the end of the semester, so you need to submit your scores. So they themselves will evaluate, and the scoring will be given from those web pages like GitHub or LeetCode or InterviewBit or Kaggle, whatever may be the case. So you may be given some scores. So based on the scores, your digital assignment 2 and 3 will be evaluated. And then apart from that, so I request each and every student to register any one online course which is having a duration of minimum 15 hours, minimum 15 hours. So one online course, either it may be in NPTEL, or it may be in Coursera, or it may be IBM Big Data University, or it may be some other foreign universities offering the course. But the course not to be registered is nothing but Udemy platform. In the case of Udemy platform, you please don't register, because once you register, you may earn a certificate. Okay, so I request all the student friends to register one online course, and what is the course you are going to register, you please inform me by next Monday. Okay, so the time will be given. So for the J component, maximum 3 in a batch. Okay, so 3 students has to do, and for digital assignment 1, so the complete exhaustive literature survey has to be done, and then for digital assignment 2, and 3, you need to analyze these 4 web pages. One is GitHub, next one is lead code, LEAD and next one is interview bit, and the next one is Kaggle. So why I am insisting in these 4 web pages, you need to go and you need to solve the open problems. From last academic year onwards, the recruiters or the companies which are hiring you for the placements. So from last year onwards, they are into a decision called so hereafter, with respect to your resume, they are not going to recruit. So what about your normal resumes, your normal programming skills, whatever you prepare, that will not work out from last academic year onwards. From this academic year onwards, okay, across the country in India or across the globe, so they are going to recruit based on your digital profile. Digital profile in the sense, you need to create a profile in the GitHub, or you need to create a profile in the lead code, or you need to create a profile in the interview bit or in the Kaggle, and they will see, so what is your profile strengths and weakness, so how you have approached the problem, so what sort of problems you have attempted, and what was your scores or what was your grades in these profiles. Based on that, so you will be observed, or you will be shortlisted, or you will be considered for the recruitment process or placement process. So keeping this in mind, I don't want you to miss any of the company opportunities or any of the industry opportunities. So the certification courses are also important, and apart from that, your digital profile is also important. So keeping these 2 things in mind, so from the School of Computer Science, almost all the faculty colleagues will be insisting only on these 2 aspects. This one is the online certification. Next one is nothing but the lead code profile, interview bit profile, Kaggle profile, or GitHub profile. Is it clear? The terms and conditions for this course. Any doubt in this?
Yes, sir, it's clear.
Yeah. So if you have any second thought, you please inform me, so that we will come to a common consensus. Okay, so let us see the introduction of soft computing for today's class. So soft computing is nothing but it is a emerging domain. The soft computing is an emerging domain, and it is trying to combine one or more subdomains or one or more fields. Okay, so so that is the soft computing. And the next one is nothing but the soft computing has been introduced by Professor Lotfi Zada. So who is the father of fuzzy? Who is the father of fuzzy concepts? So what he says, Professor Zada, according to Professor Zada, in contrast to traditional hard computing, soft computing exploits the tolerance for imprecision. Imprecision is nothing but there is no concrete decisions are required. Are not achieved, then uncertainty, I am not able to decide, and partial truth, so I don't know whether it is right or wrong, so half may be right, half may be wrong, to achieve tractability, robustness, low cost solution, and better rapport with the reality. So I am trying to find out the solutions for the tolerance for imprecision. Tolerance is nothing but some allowable limits. So for imprecision is I am unable to get a concrete decision, or I am unable to get a concrete solution, and I am uncertain in my decision making process, and I don't know whether it is right or wrong. So it may be a partial truth or it may be a complete truth. So in order to achieve or overcome these difficulties like this imprecision, uncertainty, and partial truth, okay, so I need to achieve the tractability, then I need to achieve the robustness, so and then I need to find out a low cost solutions, and then I need to have a better rapport with the applications, better rapport with the applications. So these things are required for me. Required for me with respect to soft computing domains. What do you mean by tractable? What do you mean by tractable? So all these soft computings are going to deal with the complex engineering applications. Your traditional hard computing are going to deal with the simple or normal engineering applications. And this soft computing approaches or soft computing methodologies are going to deal with the complex engineering applications. So if you say the word complex engineering applications, you need to bring down all the parameters within the control limits of the operator or of the engineer or of the technicians. So the tractability is nothing but bringing down the process into the control limits. That is considered as tractability. And robustness, it has to react or respond as per the situations or as per the inputs. Then I need to provide a low cost solution. Then I need to have a better rapport with the real situations. So what are all the main components of soft computing? One may be considered as approximate reasoning and other may be considered as search and optimization. One is considered as approximate reasoning and the next one is nothing but search and optimization. So with respect to search and optimization, these three subdomains we are combining. One is fuzzy set theory or fuzzy logic. Then next one is evolutionary computation or evolutionary algorithms, and the next one is nothing but the neural networks. So there are two types of problem solving techniques are available. So as we saw in the starting of this session, so one is considered as soft computing and other one is considered as hard computing. So what are all the various methodologies which deals with hard computing? It deals with precise models. Precise model is nothing but, so I know what will be my expected output. I know what will be my expected solution. That is considered to be the precise models. So under the precise models, you have symbolic logic reasoning will be there. Then traditional numerical modeling and such strategies will be there. Why? Because so the soft computing are nothing but search and optimizations, where your evolutionary computation or your genetic algorithms deals with optimization problems, and searching strategies deals with your neural networks. Some part of neural networks, and maximum it covers in the evolutionary algorithm. Then approximate reasoning is nothing but it covers with the fuzzy logic. Then here with respect, here it is precise, but here, so we, as per the definition, we are going to see that, so we are trying to find the solution for imprecision, uncertainty and partial truth. So the opposite of imprecision is precision, opposite of uncertainty is certainty, that is definite or concrete. Then here instead of partial truth, that may be a complete truth will be there. So wherever I have an approximation or wherever I need to optimize the results, then I go with the soft computing models or soft computing techniques. So here approximate reasoning will be one particular thing, and then here is nothing but the randomized search or optimization will be there. So what are all the techniques or what are all the domains we are going to fuse or we are going to combine? So in general, we go with neural networks as one domain and fuzzy logic, then genetic algorithm. After that, we are trying to fuse or we are going to combine these three domains. Not only these three, apart from this, you have now the extension of this neural networks, maybe the deep neural networks is there. There is nothing but your deep learning concepts there. Then machine learning will be there. Then next one is nothing but rough set theory will be there. Then apart from that, you have what you can call it as swarm intelligence is there. Swarm intelligence is there. Then apart from that, bio-inspired computing, which is part of soft computing. So all those things are nothing but as the technology grows or as there will be any advancement in the domain of computer science or in the field of artificial intelligence. So some new domains has been added up to this computational intelligence or soft computing domains. So whenever we try to mix up these two things, neural networks will have some advantages. Fuzzy logic will have some advantages. If you try to fuse these two things or if you try to combine these two things, so that may be considered as hybrid systems. Either more than one domain of soft computing techniques can be combined, then that is considered as hybrid systems or hybrid techniques. Then in the case of neural network, the DARPA neural network study, which has been introduced in the year 1988 by international press, okay, AFCEA international press, they have the persons who introduced the neural network in the year 1988. That is the first neural network study, DARPA neural network study. So it is nothing but like human brains. Human brain consists of so many neurons. You may have thousands of neurons or hundreds of neurons will be there, and each neuron in the human brain may be considered as a processing element or as a processing unit. Each neuron in the human brain can be considered as a processing element or processing unit that can be considered as neuron. The same thing here in the case of artificial neural network or DARPA neural network, whatever may be the case. Okay, the processing units or processing elements can be considered as a neurons, and in human brain it works in a parallel manner. All the neurons works in a parallel manner in order to execute certain task, and it tries to throw the results to the user. Similarly, with respect to neural networks as equivalent to the human brain, so here also the processing elements are operating in a parallel function or in a parallel mode, whose function is determined by the network structure, connection strengths, and the processing performed at the computing elements or nodes. So here, one second. So if you see this background watermarking image, so this may be considered as one particular neuron, and this is as neuron, and this is as neuron, and this one neuron. So the 4 arrow marks, you have 4 independent neurons. All these independent neurons will accept the inputs, in a parallel manner, and then it tries to process those inputs, and then it tries to throw the output to the user. That's why they call it as all the elements operates in a parallel, whose function is determined by this entire network structure. So there are so many neural network architectures are there, like you started with perceptron network, then you may go with Hip's network, then you go with the backpropagation network, then you go with counterpropagation network, then you go with the associative memory models. In associative memory models, you have auto-associative, you have hetero-associative, then ARC network, then you have deep neural network. So many network models are there. Okay, LVQ, learning vector quantization, like that. So many neural network models are there. So using that neural network model, depending on the application type. So for specific application, so you need to use a specific neural network. For all applications, same neural network structure cannot be utilized. So all these neural elements operating in parallel and is determined by the network structure. Connection strength. Connection strength is nothing but this node and other node needs to be connected, and the lines connecting one node to the other node in the parallel things will be considered as a connection strengths that may be considered as a weight values. So in the connection strengths, you may have some values. That values is considered as weight values, and the processing is performed at the computing element. This is considered as computing elements or neurons, or it may be considered as the nodes. And the next one. So according to Simon Heiken, in the year 1994, neural network is considered as a massively parallel distributed processor that has a natural propensity for storing experiential knowledge and making it available for use. And it resembles like a human brain in 2 respects. So how the knowledge is acquired by the network through learning process, and then interneuron connection strengths known as synaptic weights to store the knowledge as with respect to the human brain. So we will stop here, and we will see the other slide. First, we need to know what is soft computing. So it is a combination of fuzzy, neuro, and then evolutionary, then genetic, and then probabilistic computing. Okay, then so this is the one. So Lotfi Zada, 1981, he says that he identified a new domain called the soft computing domain, and this is a combination. Rechenberg in 1960, evolutionary computing, neural network McCall-Spit, that was the first neuron identified in the year 1943. Then again, father of fuzzy is nothing but Zada in 1965, FL, fuzzy logic. So what is the ultimate aim or objective of soft computing is to exploit the tolerance for imprecision, what we saw, then uncertainty, and approximate the reasoning and partial truth in order to achieve close resemblance with the human-like decision making. So how human reacts, how human thinks, how human acts, or how human interact with a given environment, in a given environment. So similar to that, the soft computing techniques or soft computing methodologies will provide a solution to us. So again, evolutionary computing, you may have various subdomains will be there: genetic programming, evolution strategies, then evolutionary programming, and the next one is nothing but the genetic algorithms will be there. Then apart from that, in the case of fuzzy systems, So the fuzzy system consists of the if-then rules only. In simple, fuzzy system is nothing but fuzzy system or fuzzy set theory. You call it as only if-then rules. So if-then rules is one example I can say. If the what you can call it as if the temperature is cool, then switch off the air condition. So that may be the simple if then rule in our day-to-day practice. If the temperature is cool, then switch off the air condition. Then if the temperature is high, then switch on the air condition. That may be considered as simple if rules. Then you have complicated if rules, or you consider as complex if rules. You can consider as complicated if rules or complex if rules. So complex if rules or complicated if rules may be may be formed or can be written via connectivities. Connectivities in the sense there may be considered as the connectivities. Some book they call it as, logical connectivities. For example, if I have not prepared well for the examinations, I may be failing in the examination. That is considered as simple if then rules. Then complex if then rules is nothing but so if I have prepared well and I have remembered all the answers and then I may able to clear the examinations with good scores. So here the logical connectivity is and. For example, if the project staffing in the cells is nothing but members. If the project members are adequate enough and the complexity of the problem is very low, then the solution can be obtained in a easier manner. So this you are putting it as an and connectivity. Like that, logical connectivity, you may have various connectivities are there. One may be considered as and connectivity, other may be not connectivity, other may be considered as or connectivity. So neural networks for learning and adoption. One second. So neural networks here one for consider as learning. Learning in the sense is nothing but here you have different types of learning approaches or learning procedures in the case of neural networks. So one may be considered as a supervised learning approach. Next may be considered as unsupervised learning approach, and next may be considered as the intermediate of these learning approaches, semi learning approach, that is called as semi supervised learning approaches. And these learning approaches are nothing but deals with the neural networks. So if you take supervised means, so an external entity or external force or external teacher is required. That may be considered as supervised learning. And unsupervised learning in the nothing but it may be considered as a remote location. That is nothing but the student learns by themselves. Like so the teacher asks or the faculty ask the students to deal with the digital assignments, or the teacher asks the students to deal with the J component titles. So in that case, the students surf the net, they try to understand about certain concept, and then they arrive at a decision that this is what the topic of interest I am going to choose, or I am going to select for my J component, or this is of the topic of interest I am going to select from Kaggle profile, or I am going to select from GitHub profile. So I am going to solve this particular issues. That may be considered as unsupervised learning. So without the involvement of external force or without the involvement of external entity, okay, so if the learning happens, self-learning, that is nothing but self-learning means, then that is considered as unsupervised learning approaches. Then the next one is nothing but semi-supervised will be there. Semi-supervised in the sense is nothing but it is partly between this extreme and that extreme. One is unsupervised learning approaches, and next one may be the supervised learning approaches. Then apart from that, you have reinforcement learning is there. So one more learning approach. That reinforcement learning approach is nothing but teacher expects something, but he or she does not inform what is expected by the teachers. Okay, what is expected by the teacher or what is expected by the faculty. In such cases, the student themselves will identify the need of the teacher, will understand the vision of the teacher, and then he tries to get the outcome as per the teacher's expectations or as per the faculty's expectation. That may be considered as a reinforced kind of a learning procedures. The next one is nothing but genetic algorithms for evolutionary computation. It is nothing but mimicking the human behavior, and it is used for some approximation problems or some such strategies. This genetic algorithms will be useful. So it is still growing and it is a developing field, and a few more concepts are also included over there. Okay, so with this basic introduction, so we will wind up the class today, and from next class onwards we will deal with the detailed discussions with respect. We will start neural networks first. Is it okay?
Yes, sir.
Okay, so shall we conclude? Thank you.
Thank you, sir. Thank you.
Sir, can you show the reference book once again?